How's it going, D? Hey everyone, thanks for joining. This is John, software engineer with about 10 years of experience here, and today we're working on Leetcode. Specifically, we want to enhance this 5 to 23 patterns article to create Kata, that is a practice of simple, known, and repeated problems so that doing certain patterns becomes second nature. Similar to in martial arts, you'll have like a warm-up kata. And today I'm streaming out of the Restream studio. Let me make sure the audio is working, actually. That's going to be really important. OBS was having some issue. I don't know what the problem was. All right, cool. Looks like audio is working. So if you're on TikTok, thanks for joining. And you can go to YouTube. Link is in my bio to see the full screen. If you're already on YouTube, what's up? Thanks for being here. Let me also make sure I can see the YouTube chat. Cool. Looking good. All right, so what are the 5 to 23 patterns? They're basically Leetcode data structure and algorithm patterns. So you might have heard of the blind 75, and then that was improved on by the 14 patterns. Some people still use this. It's pretty standard advice that you use the 14 patterns for algorithm prep. I have found as I teach people to code, and by the way, I do teach people to code, break into tech at laterally.io. You can sign up for free and it's open source. Also encourage you to join the community. Obviously, we build in public, we learn in public, we socially network, and we also do like games and stuff. So lots of fun over there. Check the bio for that. And so 14 articles is pretty cool, but I found that it's like a large barrier to entry for a lot of people. So I created the 5 to 23 patterns article, and it's been over a year at this point, to bring down the barrier to entry and then also go beyond the 14 patterns for the completionists, if you will. And so for a long time, I stewed on this problem of, okay, well, these are the patterns, but what specific problems should I use to learn these patterns? And I thought that I could find an elegant solution, which would be 3 to 5 problems that would cover all 7 patterns, because in many problems, you use multiple patterns. For example, you might use array operations and depth first or breadth first search. Or you might use a tree with a string, like maybe a trie. Or you might use, graph with DFS or BFS. Or sorting, or you might use like a sorting or searching algorithm on a tree. So you see these combinatorial problems. So I didn't think that I needed 7 problems to cover the 7 patterns. So, or the 5 patterns. I thought I probably could get away with less, but it's been over a year and I haven't found the right problems. So we're going to do what I call meta Leetcoding, which is we're going to take the Leetcode approach to solving the Leetcode problem. And that is make it work and then make it work better. So we're going to brute force it basically. And it seems to me the brute force solution would be to do one of each, and maybe even more than one of each. For example, in the case of like 2-sum or 3-sum, there's some variations, and you might want to just run through a few of them because they do include different patterns. So this is what I'm working through in real time with you. Let's go to the comments real quick. Ship it. Oh man, what language you're going to be using? Either Python or JavaScript. Isma says, this is right on time. I have a HackerRank assignment to complete. Are these patterns similar? The answer is yes. Thanks for being here. Let me check out Capture the Flag websites. All right, cool. So the approach that I'm going to start with is looking at the blind 75 and picking out of those and then eliminating them if they're no longer relevant. Let's also go to the 14 patterns. I don't remember if 14 patterns specifies actual problems. The other thing we're going to do is consult Leetcode itself, the frequency graph. So you need Leetcode Premium to do this. And if you have Premium, you just go to the problem set and you sort by frequency. And I want to prioritize the most used problems. So 2-sum is right there. So we're going to leverage definitely 2-sum and then 3-sum, because 3-sum captures all the lessons learned from 2-sum and more, but it's still really easy to get through. And so that's the point of the kata. Shivit says, what's your suggestion on large arrays, mainly for Leetcode competitions? I don't know. I don't understand the question there. Are you just asking about what language when you're dealing with large arrays? I think, yeah, Python and JavaScript are both fine. I guess you might get into trouble with Java because there's so many variations of array, array list, dynamic, static, and so forth. So maybe go for a dynamically allocated array language. So that would be like JavaScript or Python. Usually speed memory issues. Yeah, I'm still not sure I understand the question. If you're asking about the language so that you can get like in the top 1% or whatever, there's a few things to note there. One is that they break down the results by language anyway. So it's not like, if you get 10 milliseconds on the Java board and 10 milliseconds on the JavaScript board, you're going to be at different percentiles. Does that make sense? So that's one thing to call out. And the other is, if you're looking for the guy who's going to get you from top 20% on the leaderboard to like top 1%, that's not me. I'm not here for the micro optimizing. I'm not here for, if you write your while loop using a negative iterator, you get like 1 millisecond faster. I do not care about that stuff. I care about the patterns. Shivit says, no, not the language. Usually during competitions, if it takes too long, you time out while running. Yeah, I don't care. I don't care. I rarely run into that. If you have an optimal solution, you're right, by the way. If you have an optimal solution, you will occasionally time out just because those competition problems are relatively less battle tested, and they might set a timeout threshold that like doesn't allow for the natural runtime of JavaScript, for example. But I don't care. You can take the L on that one. The point is to pass the interviews. For me, the point is not to collect the Leetcode points. Like I don't care about that stuff. Does that make sense? So that's my perspective. But yeah, you're right. That does happen sometimes, but it's pretty rare, right? Like I'll go through 3 Leetcode competitions and I might hit one like that. They say, fair, just wondering, thanks. Yeah, thanks for being here. Do you have a meta interview coming up? Actually, I do. Although that is not the reason for the title Meta Leetcode. The title Meta Leetcode is applying algorithm solutions to solve the particular problem of what problems to solve. So it's a meta problem. So that's why I called it Meta Leetcoding. Although, yes, I also have a meta interview coming up as it happens. Okay, cool. Create hello world is the most ridiculous thing. You don't need to even practice that. It's just you just return hello world. Okay, so we like 3-sum. Let's go to the 14 patterns article. 14 patterns to ace any article. Oh, best of luck. Thank you so much. Do you know if iOS also require Leetcode? Some of them do, but to a lesser extent is the word on the street. I will say I'm not a mobile developer, so I only know secondhand from talking to people who are mobile developers. Sliding window, we need it for sure. Let's see, is that in here? Sliding. I think I consider that an array manipulation. Oh, that would be an interval problem. You can look at it either way. So yeah, we need sliding window, definitely. 2 pointers, definitely need it. Where are the problems? So we have maximum subarray, cool. String anagrams, I don't know. At what level do we want this kata to be? So obviously, like solving a hard is hard. But if you've memorized it, can you get through the kata quickly? Which company are you working in right now? It's a company called Upstart, UPST on the ticker. So let's highlight some goals of Leetcode kata. 1, it should warm my brain, not deplete it. I want to kata before coding interview. bring to front of brain many useful algorithms. Okay, so it should warm my brain, it should not deplete it. Quick question, any tips on imposter syndrome? I think a few. One is use objective certifications in a portfolio so that you have external verification of your skill, so that you don't need to do this internal debate. Am I good enough? I don't know. You have these external sources of validation. Okay, so that's one. So get a portfolio and get some certifications. Two is stay on your interview prep grind even if you're employed. So that if you tell yourself, holy shit, I might get fired, I'm such an imposter, I don't know what I'm doing, you can respond by saying, so what, I'll just get a new job. Okay, so those are two ways to mute the inner critic. One is with external validation, and two is with continuous interview preparation. This is going to be a bigger problem earlier in your career. And that is when continuous interview preparation is even more useful, because job hopping as like a staff engineer is a lot less beneficial than job hopping as a junior, because you can rapidly go from junior to senior in as little as 3 years. You're not going to go from like senior to like what's above staff? I don't know. Senior distinguished or distinguished. That's not going to happen in 3 years, homie. Patience would be the third move. Patience would be the third move. So you have your external validation, you have interview prep, especially as a junior, and then by the time you get to senior, you can just expect that it will be less of a problem, because over time you will have a natural competency. You'll feel that in yourself. You'll be able to you'll have done so many things that you'll have gotten like the feeling that it's not like you know how to do everything. You actually never get to that feeling. And if you do, that's a problem. But you get to the point where you know when you should be worried, which is not often, actually. And that if you do get worried, you know how to handle it. Does that make sense? Thanks for the likes. Okay, goals of Leetcode Kata. It should warm my brain, not deplete it. Under 30-minute completion time. Covers the 5 basic patterns from 5 to 23 patterns article. Optional. Include 2, 3, 4 sums and or variations of them. Okay. Take some probs from 14 patterns and blind 75. Oh, this is another non-optional goal. Represent high frequency problems according to the current Leetcode graph, and that is late November 2023. Cool. All right, so I think these are the good high-level goals. And so we're going to start by, let me just grab this. Has anyone done this? I don't think this was even possible to do a year ago. I'm just going to grab the 14 patterns article and say, hey, GPT, pick the best problems out of this. Okay, so we go over to this Elven Rogue in the Forest. By the way, if you're into role playing, follow the page as well. I do some game stuff, but that's not what we're doing today. Read this article and extract the specific Leetcode or algorithm problems included. Bam, so I can just dump it. I don't need to sort through and collate a list, right? We love it. Two heaps, I do not give a shit about two heaps. Okay, I do want a topological sort, yeah. So which of these? Let's go look at them. Probably one of these. Squaring a sorted array is actually too easy. 2 pointers is in the threesome. Arguably, I don't need fast and slow and 2 pointers. That's fine. We can do both of them. So let's check out threesome and foursome. So twosome is a super frequently asked question. It's also very easy. And so isn't there a way to navigate to like related similar questions? Here we go. So here's threesome and foursome, and then we have the variations of twosome. Cool, so foursome is still considered a medium, so maybe we should do that. And then input array is sorted. That's an interesting one. Data structure design, no. Subarray sum is K. Thanks for the follow. Quick reminder, I'm on YouTube full screen if you're interested in full screen. Number of pairs of strings with concatenation equal to, nope. Nope, 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 nope. Max number of k-sum pairs. That seems interesting. Highest edge score is interesting. That's a totally different algorithm though, right? And then this one, subarrays with equal sum. I'm gonna click it, not because I think it's like interesting variation of twosome, but because I definitely need a subarray problem. Partition equals subset sum, 2 non-overlapping subarrays each with target sum. I don't like any of these. Okay, sub. Ooh, palindromic substring. That could be good. So something palindromic is good for a string problem. Longest substring without repeating characters. This one is a really good one. Okay. This is going to be a string candidate. Did you do the contest this morning? I did not. How was it? Did you do it? Also, what do you mean morning? They're like super late at night for me. Where are you from? Maybe that's like a location in the world thing. Roman to integer is kind of fun.
You are this close to going to bed for the night because I'm not in the mood. Sit.
Oh, is the video focused for y'all? I guess that's fine. Oh, that's my favorite question to ask during interviews. Oh, which one? Was it the Roman numeral question or something else? The palindrome. Oh, okay. Yeah, there's a few different palindrome questions. We definitely need one of them. I don't want to use the basic palindrome. I think basic palindrome is too easy. but maybe 5 or 3, these are kind of cool. Yeah, like 9 is too easy. All right, so let's look in the sum variations. How long is the solution? That's what I'm trying to remember. So we'll look for a Python solution. Megapost. I love the ones that have a megapost, by the way. It makes it just easier to see. It's going to go through the relation to sum 2. What is 2 sum 2? Problem says it's not zero based. Is 2 sum 2 the one where we know the input is sorted? I wish they would just say that we knew the input is sorted. Here the problem asks for ascending order, and since the values indices in scene has always lower indices than your current number, it should come first. It has always lower number than your current number because the input is sorted. So 2 sum 2 means the input is sorted. Okay, well, I could have just clicked it. That would have been, okay, great. 9:30 a.m. EST this morning. There's another one 9:30 p.m. tonight. You know what? Wow, I didn't realize they had morning ones. Huh, I guess that's on me. I wasn't planning on doing the 9:30 p.m., but we'll see if I do a second Leetcode stream today. I guess I probably should, right? 3 sum. And here's the solution to 3 sum. This is a great example, I think, of one that is, if you haven't done it before, it could take some time to bang it out, but it's a good Kata problem where if you know, it's basically 2 algorithms. And that's why I like 3 sum more than 2 sum, because 2 sum, it's like 1 algorithm. 3 sum, it's a wrapper on an algorithm. So it's kind of like 2 algorithms. So I like 3 sum more. And then I forget if 4 sum is just basically 3 sum with another layer, or if there's something interesting about it. Definitely need a recursive. So we literally do 2 sum and then we wrap it here. So 4 sum is we sort the numbers and then they grab a helper function. Four is going to be just like that, it's 4 sum as opposed to 5 sum or something like that. So I like that it's generalized. That's really cool. That really crystallizes the pattern itself. And this is not too long to write. Look at this. Combination sum. What about this? I don't post combination sum here because it's basically this problem a little bit easier. Can be solved with DFS. I want a tree-based DFS though. This is really cool. Dang. It would be nice to hit DFS twice, wouldn't it? Okay, fine. The Kata can have an optional one. So we'll do 4 sum. Look, we're really brute forcing it, and we can shrink the list later. So this is like the too long brute force list. 2 sum 2 input is sorted. 4 sum combination sum optional. Probably we're going to nix combination sum because if it says optional, like I already have 3 patterns for basically, like 3 problems for basically 1 pattern. So that's already bad, right? It's probably going to nix that one. Although it said it was DFS, which is a different pattern. So this is a non-tree DFS. All right. And then it has it's worth calling out that it has a mega post. Problems that have a mega post are going to be easier to grok, I think. We'll give this like a red wrapper to say that they all three together have the mega post. Okay. So here's a node problem. We might keep that around. Subarrays with equal sum. I don't like it. Mega post, cool. We closed it. This one, we did it. Subarray sum equals k. I think I like this one. Subarray sum equals k. Max number of k sum pairs. This is an array-based, an array problem. So let me slide this over and we'll deal with array problems kind of like separately. Subarray sum equals k is an array problem, okay? Node, we'll slide over the node. Longest substring without repeated characters. Here's a 38 upvotes. Yeah. So this one has a lot more upvotes. So is this more, and this has a cool editorial solution. So is this one more frequent is going to be my question. Well, I guess they both have an editorial solution. Sub, there's maximum subarray. Subarray sum equals k. All right, it looks like these are the two to do. Because they're very high frequency ask, right? Subarray sum. Oh, this is a different thing. Substring without repeating characters. I do want a palindrome. So I think longest palindromic string. Let's look at the solutions. Manisher's algorithm, I don't like it. If it's, I'll glance at it, but if it's one where it's like, you know, this magic algorithm and it's like, I'm not here for it. When tackling the problem of finding the longest substring, one might initially think of generating all possible substrings and checking each for palindromicity. However, this approach is a little inefficient. It's like very inefficient, right? Wouldn't you want to try? What do you mean? All possible substrings and checking each for palindromicity. Oh, yeah, no, I get the logic. Because this is saying anywhere in the substring. The offset could be anything. So it would need to be multiplied by n. So what is it, n squared? So what's the brute force solution? Is it n squared? Time complexity n cubed on a brute force. Why would you need to do n cubed? Not sure I understand that. Zara, deciding which problems to do next. Basically, yeah. Thanks for the follow, Gabe. I'm trying to collect a group of problems that touches on most of the common algorithms and that you can do them as like a warm-up before your interview. Does that make sense? All right, let's look at this algorithm. Does this get it down to n squared? I feel like you should be able to solve this in n squared. Whoa, it's O of n. See, this is like one of those like weird magic ones, isn't it? I mean, that's awesome. Good on them. They did this in linear. All right, let's read this just for curiosity's sake. Transform the original string to simplify the algorithm. Add special characters. Oh, is it a regex thing? Blind 75 or Leetcode 150 is a generic list to prepare. Yep, yeah, I know. So we might pull some of those. I like to go by frequency though. For every character in the transformed string, we consider it as a potential center for a palindrome. A potential center? Okay. Smart. Oh, and then you're hashing it? So it is n squared inclusive of memory. Yo, that is super smart. That's tricky to implement, no? Whoa, it's super simple to implement. That's wild, dude. That's a cool algorithm. Thanks, I hate it. So this is not going to be in there, but good job to, I guess, Manisher. That's really cool. Longest palindromic substring. So we'll close this one. Longest substring without repeating characters. Yeah, this is a good one. This is pretty common, right? So you got to hit every letter O of N. Can you sort it? N log N. Let's see. Is it just O of N? Why would it be longer than that? Look for the Python solution. We got a step-by-step visualization of the sliding window. Yeah, this looks good. Brute force is n squared. Yeah, we hate it. But there's better than brute force, right? Each check for duplicate characters runs in O of N. We can reduce to O of N. Yeah. Okay, great. This is a wonderful one because you can brute force it. If I'm in an interview, I can implement a brute force, which is awful, and then I can improve it by 2 orders of magnitude, which is impressive. Great, I love it. Longest substring without repeating characters, and this will be a string problem and sliding window problem. So this is one of those elegant problems that is able to knock out 2 patterns in one problem. Thanks for the follow. And we'll give it doesn't have a mega post, but this has a it's well explained basically. What do you mean meta? Interviewing with them soon. What's up, Hayden? Yeah, so this is meta Leetcode. What that means is we're applying the Leetcode common Leetcode solutions to decide which Leetcode problems to solve. So the make it work, then make it work better. So brute forcing it right now. Okay. So this one is well explained. I really like this one. Longest substring without repeating characters. I really like this one. Okay. What's next? So we got array, graph, interval. We didn't get a graph one, did we? I don't even think we got an array one. What did we do? What is two-sum? Is two-sum an array problem? I guess it is. I guess it is. Okay. Celebrate sum equals k. How about a graph problem? Node with highest edge score. So this is going to be available to solve in BFS and DFS. They're connected graphs, right? They're directed graphs. Interesting. Okay, let's jump to the solutions. There's no editorial solution. One pass solution. That's awesome. Approaches array traversal. Great. For I in range. Oh, is this like a bogus? This is like a super easy problem. Node with highest edge. This one has a cycle in it. Is 1 year long enough to learn a coding language? Absolutely yes. Yurichi says, saw this problem in an interview recently. Cool, which one? I didn't catch which one you were talking about. Do you mean this node with highest edge one? Quick reminder, if you're on TikTok, you can go over to YouTube and see the full screen. Some sort of problem that has edge scores seems like good to run through. This is a 2-pass. This seems like too easy. I like the concept, but it seems like too easy. Okay, so is there like related? Eric says, I'll check YouTube out. A little tough to see on the screen sometimes. Yep, fair enough. Similar to questions, to sum, characters by frequency. Yeah, this one's out. Bye. Buy and sell stock is like a common one. Let's bring that over here. We might do that just because it's so common, right? Trapping rainwater. Is this a DP? Where does it have the tags? Somewhere on these it has like tags of their kind. Yeah, DP. What's the palindrome one? Is it longest palindromic substring? Yeah, so you just look through the string and you want to find like the longest palindromic substring, right? Whatever that is. So that's a pretty commonly asked one. You just do the typical palindrome check multiplied by n, if I'm not mistaken. So I think it's isn't it n squared? Let's take a look. I guess you can build up a hash, so you could probably do O of n. That would be trickier to implement. I feel like I was just here, wasn't I? Okay, so the brute force is n cubed. No way. No way. And then, yeah, and then Mancher's algorithm does it in linear time. I think I can beat the brute force, but I don't think in an interview I would remember this random algorithm. So I'd probably end up mid. Not a good look. Still trying to understand time classes. Yeah, asymptotic complexity. It's an interesting thing. At interview time, we just care about the worst case performance generally from an asymptotic perspective. Thanks for the follow. Merge sorted array. Merge sort's cool. LRU cache. I feel like this is a good one to do. Design a data structure that follows the constraints of least recently used cache. Hello, Luffy. What up? What up? What's up? I want a problem where I implement and use an LRU cache. LRU cache medium, LFU cache. Huh. And these are all locked. See, Python, we just have an LRU cache annotation we can use. It's very cheaty though, isn't it? Maybe. All right. So what this would go under linked list basically. What does ON means in terms of an algorithm? It means there are a finite number, so like a constant number k, like 1, 2, 3, 4, 5. There are a finite number of operations per input element. So if you pass an array through the algorithm, it will be constantly performant. It will scale constantly. So if you double the input size, it's going to take twice as long. That's the point of O of n. That's the point of O of n. Because we care about scaling, right? You want to work at Amazon, Amazon cares about scaling. Okay. So we got the sliding window taken care of, I think. Maximum sub array, longest string with k distinct characters. I like this one. Maybe. We want to check frequency. Okay. Lil Dicky joined. The real Lil Dicky. What's up? What's up, Lil Dicky? 2 pointers. Luffy says, where can I find those patterns? So this article is the 14 patterns article. Now, I will recommend you look at the 5 to 23 patterns article. Unless you're like a senior, then go for 14. But if you're at the like junior level, I think 5 to 23 is going to be better. Anyways, those are the articles. I do want a fast and slow pointer. I feel like if I'm doing fast and slow, then I don't need a different 2 pointers. Plus, if I'm already doing like 2-sum, the 2-sum solution has pointers in it, right? Let's go look at the 4-sum again. So I don't want trapping rainwater. I know this is like a popular DP question. If you ask me trapping rainwater in an interview, I'm gonna be so pissed, dude, literally. The Leetcode 75, that's interesting. We'll take a look at that. Top interview 150. Okay, we're looking up 4-sum. And then here's 4-sum, and let's look at the solution. Imagine writing this in Ruby. Like, why would you do that? I get nom flashbacks from that problem. That's hilarious. Python, brute force, better, optimal. I like it. Look at that. This is great. Really good explanation. And so better, we're going to have the hash map. It's a default dict, int dict. Thanks for the follow. Add tuple sorted. That's weird. And let's look at the optimal one. Avoid duplicates while moving I. So we sort, and we're in range into to n minus 3. Low and high, these are pointers, right? Yeah, so it's going to include the 2 pointers. Let's see in the explanation. Fix 2 pointers, yeah. Okay, so for sum includes, this is why I love for sum, dude. It's a fucking great question. Okay. So now we're going back to the patterns. There's the 14 patterns. And what we're saying is, or let me go to my GPT collation. So sliding window is covered, I think, right? Or we'll do the subarray thing for that. Is there a different sub? That's the only subarray problem in the list. Probably I want maximum sub. Probably I want that one. So 2 pointers, we're good. Fast and slow pointers, cycle in a circular array. Ooh, actually, it will be good to have a cycle problem. It will be good to have a cycle problem. So let's see how long is the solution to this problem. Because when I think about the kata, one of the things that I care about is how long does it take me to type it out? Literally, I care. Merge sorted array. What's this? So let's do. It's called circular array loop now, is it? We're playing a game involving a circular array of non-zero integers, okay? If it's positive, move forward. If it's negative, move backwards. Cool. Since the array is circular, you may assume that moving forward from the last element puts you on the first element. Oh, shit. That makes sense. Sorry. Okay, so you're like going in a loop. A cycle consists of a sequence of indices where you end up where you started, right? You end up where you started. Honestly, if it's a circle, how does it not have a cycle is my question. But anyway. Every nums sequence J is either all positive or all negative. What? Let me think about that. Oh, it's giving the multiple conditions of a cycle. It's not saying that for all inputs. It's saying that if you're it has to be a unidirectional cycle is what it's saying. Got it. So if you're doing like a wave, positive, negative, forward, backward, it's not going to count that. And then you can't do like a self loop. Fine. Okay, well, that answers the question. How could you have a circle with no cycle? Is because if you go like 1 minus 1, it's not counting that as a cycle. So this is kind of interesting. Could you solve an O of n? Ooh, okay. This is highly optimizable. Related topics, array, hash table, 2 pointers. The problem there is these are all topics I've already taken care of. So bummer. I almost liked it. Oh, but it's got more thumbs down than thumbs ups. So I don't like that. There's not any related questions. So this is not the one decoding cycles in an array. So this is not the one that the guy was talking about then. Circular array loop, circular array loop. Thanks for the follow. Circular array loop. It looks like everyone is talking about this problem, but it's heavily hated. All right, we'll skip it then. It would be good. Is there another one on this list with cycle? What about the blind 75? The grind 75, yikes. So let's look for cycle. Detect cycle in a linked list, okay. That's good. Good, and I can use this as my linked list question, right? Cool. So here, this is Tech Rally, consolidating and updating the blind 75. This is cool. What is this? Top 5 interviewing patterns, bro. I came up with the top 5, bro. Look at this. DFS is that much? That's cool. That's good to know. Oh, yeah, overall. Google has hella DP, really? It's terrible. How old is this article, though? Seven months ago, eh? Definitely going to need to watch this later. Maybe I should probably do a reaction video to this, eh? I really like this. So I make a practice of looking at the top problems by frequency, and then I go problem to pattern, but they straight up looked directly at the pattern by frequency, which is awesome. See if I can grab this. And so honestly, if it's under 5%, like I don't care. If it's under 5%, I don't care. Hash. Oh, wow, hash is under 5%. That's wild. Binary, actually, okay, maybe I'm a liar. Maybe if it's under 3%, I don't care. Because I do care about binary search and stacks and queues, right? So DP and heap, yeah, I don't give a care about heap. Especially if I'm interviewing in Python. If you're interviewing in Java or like C or something where you care about memory allocation, I get it. But dude, if you ask me a heap question, I'm just going to assume that you just like don't want me to work with you. So let's resize this, stretch skew. We'll go 50. Okay. Ooh, no, I wanted 50 in both directions, my guy. I'm getting kind of hungry, chat. What should I get to eat? So that's cool, but we need a bit more space. Yeah, that's cool. This is worth doing the whole research. This thing right here was worth today's research stream for real. I don't think y'all know how cool this is. All right, cool. So linked list cycle. I like it. It gets the pattern of interest, but it's an easy problem. So I'm going to write it down. Linked list 2 pointers. I'm going to write it down, but I do have some hesitation because it's like maybe too easy. But let's go ahead and write it down. Okay, cool. Task scheduling. Oh, and minimum. These both look good, actually. These both look good. Whoa, is my phone super hot? That's crazy. My phone is like really hot. That's crazy. Okay, longest palindrome. We don't want this one. LRU cache, we maybe'd it. LRU cache, and that's for a linked list, but okay, we maybe'd it. Let's close this. Longest substring without repeating characters. Do we grab it? Yeah, we grabbed this one. This is a winner for sure. For sure, my guy. Chat, drop it if you have like a problem, not just your favorite problem because you enjoy doing it, a problem that you think is insightful. Ideally, it points to more than one pattern. I really don't like these problems like, like coin change, where it's like, it does this one thing and then you memorize the one thing and then you can solve the problem easily and everyone else fails. No, I want an insightful problem. Okay, so here we are. We got the 5 to 23 patterns. Array, I think we're covered. Graph, we still got to do graph. Interval, we're good. Linked list, we're good. Matrix, string, tree. String, we're good. So remaining matrix tree graph. Let me jot down a note. Remaining matrix tree graph. Okay. Sliding window, we're good. I didn't get a fast and slow. So optionals, fast and slow. And 2 would be, I think I got a sliding window, but specifically a, not even sliding window, just a subarray. A subarray K type would be good. And then we need to do sorts. But sort is rolled into a lot of these problems, but in a lot of the cases where it is rolled in, we're just doing dot sort. We're not actually implementing the sort, eh? Specifically topological. Does this little graph that I found talk about topological? It doesn't specifically pull it out, does it? Okay. Pulls out binary search. So we'll do specifically topological plus binary. Week 5 DP. I don't care. More data structures. Oh, the tree is nice. Try. Ah! I feel like a try is a good optional. It's a real nice one that can help you sometimes, for sure. Linked list cycle. So we grabbed this one, right? Linked list cycle. Yep. Okay. This is still Tech Rally, isn't it? Oof. DFS, BFS 2 pointers, for sure. Invert a binary tree. Is this an easy? It's an easy, right? What's something that builds on this? Related. Reverse odd levels of a binary tree. Is this one even asked? It's so weird. Yeah, no. That's an interesting problem, but no. Okay, let's close that. Course schedule, number of islands. Those both sound good. Course schedule. $15K on the up, so it seems actually asked about 6K on the solutions. DFS, BFS, topological sort graph. Ooh, this looks like I need it. It's hitting all the things. Minimum height trees, course schedule. Oh, it's a series. Course schedule 2 and 3. I love series problems. One of the reasons I like series problems is if you are asked a problem anywhere in the neighborhood, you can sound really intelligent because you can solve the problem at hand. You're prepared for variations, and you can even sort of like chat through alternatives even if the interviewer didn't bring them up. Makes you sound really intelligent. So is minimum height tree the same one recommended over here? Minimum height of a tree, yeah. And task scheduling. So the course scheduling we can do in lieu of that. So this is great. Course schedule 1, 2, 3. And that is really good for a Kata too, because is the solution for 2 going to build on the solution for 3? You know, with like 2 sum, 3 sum. Let me just write it down so I don't forget. Minimum height of a tree. Minimum height trees. Or is that the same problem? Minimum height trees, minimum height of a tree? Minimum height trees, minimum height trees. This is the same one. This is what we usually mean, right? Maybe they changed the name. Minimum height trees is not different from minimum height of a tree. Minimum depth binary tree. I've definitely been asked this one before. I don't know what company, dude. Sorry. And you're just going to go, boom, it's just a DFS, right? I guess you could do BFS. You want to shoot down all the branches and then find the minimum depth. Yeah, so then you have a short circuiter. This could be good just in terms of like a warm-up, right? Which is kind of the whole point. Minimum height trees, minimum depth. This is an optional. And it's 310 minimum height trees. Good to have the numbers. Okay. Close this, close this. We want to keep this article around. Got this. Schedule 1, 2, 3, and we want to look at the kinds for this. So this is greedy. See, this one I don't mind if it's like, it's not a DP problem that's sort of disconnected from reality. It's literally a change up to a problem that has an elegant solution, and it's like elegance breaking. That's like an interesting case to me. So greedy sorting, priority queue. What sort of sorting? Is it a binary sort? Let's look through the solutions here. Using a heap. I really don't like it. Whoa, it's super easy to write. Seriously? How, dude? Is this a global or something? A. Okay, so it's like a built-in. We start learning courses with the earliest closing date first. If we find a course that we can't fit We can unlearn one of the previous course in order to fit it in. We can safely unlearn a previous course because it closes earlier. There is no way for it to be picked up again later. We can safely unlearn because it closes earlier. There's no way for it to be picked up again later. Yeah, that makes sense. Okay, so it's the priority queue, and it's like saving us on memory. And if we have to do any operation over the priority queue, it's a shorter distance. I think this is actually great. Is that the only solution? Python only supports the min heap, so negate the value when popped push to treat it as a max heap. Move forward till you can, and when you can't move, leave out something from behind that will optimize the current state. Yep. So this is just prioritization on the queue. Dropping a longer duration course that we took before and taking in a shorter duration will optimize our current state. Because it will leave more room. Yeah. I mean, maybe I should go back and reread the problem, but if you can get equal course credit for like a shorter course, that'll give you more space for sure. So this definitely feels like an optional, this course schedule free, it definitely feels optional because it's dealing with a priority queue. I'm not seeing where the sorting comes in. Are they just running a sort up at the top? Yeah, okay, fine. So there's like a quick sort. Sorting is not a key component of this problem. Really, it's all about the priority queue. So actually, I don't care too much about this problem. Uh, 2.8%. I really don't care about it, but it's also really easy to solve. So it's hard to, so it makes me want to throw it out, except that it's also part of a series, which kind of makes me want to keep it in, except that I'm constrained. So we'll include it as an optional. Let me go look at at 2. If course scheduling 2 is also a priority queue, I'm going to be like, throw all this out, throw all this out. So course schedule 3 is about the priority queue. Okay, let's go look at 2. Parallel courses, whoa. Does that make it way better? Ooh, golly. Let's look at the solution. It's not too bad. Not too bad to write it out. So this is another optional. All right. If 2 is not, oh, TikTok access one, that's kind of crazy. If this one is not like useful, then the whole bonus for being a set really gets thrown out. DFS, BFS, graph, topological. Okay, that's good. So it's not using the priority queue anymore. BFS, DFS, I want to see Python, not Ruby. Ideally, it's a rough brute force and then an optimized recursive DFS. What's up? Yeah.
What I have to say is, I wanted to watch an iPad, so I was watching noise, so it died.
Oh man, the battery ran out.
Yeah, and I still want to watch an iPad, but always is dead, and I have an iPad, and I couldn't find it.
That stinks. What about watching the big TV?
You know, I kind of feel bored if I watch that TV. I don't feel bored when I watch my iPad.
All right. So give me 5 minutes and then I'll come help you. But for now, you can either watch the big TV or play in a play area.
I want to play the player.
Can you close my door, please?
Yes.
Thank you. Bye.
Bye.
What's up, Mike is the best. I agree. Thank you. Thank you. He is 5 now. Quick reminder, if you're on TikTok, you can go over to YouTube and see the full screen. Link is in my bio. Okay, so we like course schedule 2, basically. And let's go look at course schedule 1. Ooh, Alien Dictionary. That was really fun. I think I did that in a competition. So also BFS, DFS. Okay, good. So you get 2 hits of that DFS that you need. Course schedule 1 and 2. Let's do a green wrapper on those. So I remember those are the essential ones. Course schedule 1 and 2. And then the others are optional. And so now we've covered BFS, DFS. Let's go back to the list here. So we covered tree. We still need matrix and graph. And then we have some optionals. Whoa, that is not what I want to do right now. More optionals. Okay. Okay. The matrix and the graph. I think I already have graph covered somewhere in here. Do I not? List is too messy so that I'm not tracking very well. Alien Dictionary is also recommended under the Blind 75. I don't think we need it though. Well, it says it's graph. I think we already did. I think we already have graph. Maximum product subarray. Maximum subarray. Does one build on the other? Maximum subarray, similar, maximum product subarray. So let's go to the solutions. Maximum subarray, maximum product subarray. Give an integer array, nums find subarray that has the largest product and return the product. Okay. Definitely want to cache that product, right? You don't want to be doing multiplication over and over. I feel like it's the same solution, isn't it? I mean, they're going to be trivially different. Your last submission beats 8% of others. Okay, cool. Kadane's algo. Dude, I'm not. Don't ask me about Kadane's algo. Get out of here. All right, I don't want either of these. Kadane's algorithm. Ooh, word search. Yeah, I like word search. This is not a premium one. Okay. What about one of these ones where you have to like do minimum steps or something like that? I feel like one of those would be good. Return all the elements of the matrix in spot. This feels like too easy, doesn't it? You're just offsetting by I, like plus or minus I. We can do it just for like warm up kicks or whatever. The solution here should be terse, I think. Let me double check. It's got to be in under 20 lines for sure. Maybe under 10 lines. Bro, no way. That's way longer than I thought it was going to be. Where's the time complexity? Did I just click on like the wrong thing? Spiral matrix. Okay. I'm like, why is it talking about words, dude? I'm so confused. Okay, whatever. It's a little longer than I thought it would be, but not crazy. Where's the complexity analysis? I plan to give for the next 10 subscribers. Dude, whatever, man. Four stages of the problem. Pop first row and put it as it is. What? O-N. Yeah, right? I'm not even sure why I need the space complexity. Yeah, I think it was. I'm being slow. Sorry. This has a bit of recursion here.
Are you being slow or is it time?
It's time.
Okay. So, can you help me now?
Yeah, I will. All right, y'all. So matrix and graph. I think there's two different matrix problems here, spiral matrix and word search. In theory, I don't need both of them, but I'm going to wrap the stream up. And so I'm going to use both of them for now. And then I think we already have graph covered, but I will write this all up and I will get you the article soon. So make sure to follow the page and you can see the finalized list. But basically, like this is pretty much the list. Talk to you later. Bye.
Dad, can I draw on the wall?
Nope.
Nope. Okay. But that also means that it can't run on this.
It's not moving.
But if it will move, I just can't run on it.
Oh, I didn't stop the YouTube stream. Yeah, it's not running, so it's not moving, so you shouldn't run on it.
Okay. Dad, can we get the iPad now?
Did you not hear me? I said I need to stop the stream, and then I can.
Okay.
Are you just looking at your own face? So the camera's right here. Don't do that. Say bye.